Okay, so we went through vectors. List is going to behave similarly. You'll go look those up. You have a lot of the functions are the same. Notice that with the queue, and when you move on to queue and stack, and say that real quick, you really only have push and pop. You don't have a push back or whatnot because it's a queue. DQ, you actually have the options to push at either end. Now a set, we'll go ahead and look at a set real quick. We don't really go into sets too much in this course. Let's see, C++ set. But they are used. You have to think of it, you did sets, if you do sets in math, that's what it's really supposed to represent, some type of mathematical set. So you can create them, you can still do, you can iterate through them, although they're not the most efficient for iterating. You know, find out if they're empty, their size. You can insert elements, erase. Wow, you can do observers, that's cool. But the big thing is find. Oh, and here I guess their set, they allow multiple values. So you can find, get an iterator to an element, find the element in the set, and then it looks like you can actually count them in this one as well. It looks like lower bound, upper bound. The cool thing about sets are when you start getting into algorithms, you can do the intersection. What elements are the same in both sets, or a union produce a set that is of both elements as well, and they're a little more efficient in those regards. All right, map. Map is we're gonna go talk a little bit more about maps actually in the next class. But with a map, it's just like a hash map or a hash table where, well, you can do the subscript operator with a key. You have your key value pairs, and you have this key mapped to some value. So you do the operator sub some key that'll give you its value. That's the get from Java. Of course, you can insert, you can erase things, just like with an array. And naturally, you can iterate through it if you need to as well. Okay. So that's a quick recap on those. Right now, you should be confident about the first, vector through stacks. The second two you're not too confident about. That's okay. We'll be getting to those in class. Any questions on those containers before I move on? All right. Let's see, sequence containers. All right, so C++ does distinguish between regular containers and sequence containers. Sequence just holds, obviously, the values in sequence. So it's very efficient to iterate through them. Vectors is one, list, DQ are the sequence containers. Okay, list as well. Associative containers, these are going to be with your hash maps. This is what I was talking about with your key value pairs, not sequential, but you use a key to access it. Typically it's a number or a string that maps to something. Very common, you'll have a hash map of social security numbers maybe to a student object or something. All right, we talked about a set stores the number of items which contain a certain key. A map is the key value pair. Here we are. Set and map only allow one key of each value. Multi-set and multi-map allow multiple, that's nice, identical key map values. So that's how you can tell whether you want to have more than one or just only keep them unique. Use set or multi-set, map versus multi-map. All right, we did this in class, but let's look at it pictorially just to make sure. You can actually initialize the array just like this. Notice that they create the array statically. They pass a pointer to the beginning and then a pointer to the end. Notice that that's how they decide to allocate the memory. A little different than how we did it in class. So it starts back here. If you want to pop the back, it'll get rid of the 13. If you want to push the back with the 15, it allocates it to the end. And then v.begin always points to the beginning. V sub 3 is the fourth element, or the element at the third index. Or index 3, sorry. Let's see if we, excuse me, can read this code correctly. What would be the output here? Okay, how about this one?
It's the array just reversed.
So it'd be
8, 17, 3, 12.
And how many elements would be in the vector technically after the end? None, because you popped them all. Or you deleted them.
But the capacity would stay the same?
In general, yes.
Okay.
I can't say, I can't guarantee the capacity will stay the same, but I would suspect a good implementation would keep the capacity around. It's called, what is it called? Temporal, not temporal locality, but temporal usage. Basically, you're going, it's temporal property. You used it, you're probably going to use it again pretty soon.
Question.
Yes.
Well, actually, it wouldn't apply. But if you, I was gonna say, do you have to delete a vector, but then with declaring it on the stack,
You would do it, yeah.
you have to delete it?
If it's declared on the stack, it's going to automatically have its destructor called, which would free up the memory for you. Good question. Well, let's confirm that by running Valgrind and see what it does on our program. All blocks are free. No, 7 allocations. So it did a lot of allocations internally, but it freed them automatically because we created the vector on the stack. Now, if we create the vector on the heap, we would still need to call delete vector when we're done with it. But since it's created on the stack, we do not. That's a good question. Any others? All right. Okay, there are a lot of fancy attributes that you can do with vectors as well as with lists and the rest. This is not just limited to vectors. Just vectors are the easiest to explain because I think we all have a good handle on how arrays work, right? Right. Okay, good. Good. So the first one creates a vector of 1,000, which uses the default date constructor for each of the 1,000 elements. Notice that we're doing it on a class called date. I'm just assuming we created that class somewhere else. On the second one, you can have creates 10 of them, but initializes all elements, passing in a certain constructor of 17, 12, and 1999. So you can specify how these ones are created. Later on, initialize vector y with vector x, aka the copy constructor that we've been implementing. So they've implemented the copy constructor just like we have done it. So if you ever need to create a copy of vector, it's pretty straightforward. Everyone good with this? Iterators, I showed you how they work, so let's go look at them pictorially. They call them pointer-like entities. Notice that we were dereferencing the iterator when we want to access an element. If you go back here, let's go and look at the code. Notice when we were going through it and we wanted to print the element, we dereferenced the pointer. And then when we wanted to go to the next element, we incremented the iterator, is really the better way of saying it. Now, does this have to be a pointer? Nope, because they overload the plus and the dereference operator to have it work or function in the way we assume a pointer would. Okay. So iterating, you usually move from one to the next. All right, I think we got that. Right, John?
Yeah.
Okay. Oh, good. At least we're there. Notice that the begin points to the first element and the end points to after the last element. You can have multiple iterators jumping around your vector all you want. You can go happy with this. You can create many copies of iterators. They're good with that. Find out if two iterators will point to the same thing by just asking if they're equal to each other. All right, what do we got here? This is just going to print out, okay. First element of V is, of course, 12. This would increment it to point to 3, and then this would set it to point to the last. Know that I'd do V dot end minus 1.
It says it initializes it by saying V of R, ARR, comma, ARR plus 4.
Mhm.
So it passes it the array, and then what does it pass?
It's passing a pointer to the first element of the array and then it's passing a pointer to, what is it, after the last element of the array.
So it's passing beginning and end.
Yes.
So that's the way you have to initialize a vector if you have an array?
Yes. And I haven't looked it up, but I bet you the other data structures are the same thing in the STL.
Okay.
They're going to all follow this pattern. They try to make them all follow the pattern, let me put it that way. Okay. Any other questions on this code?
When you do begin and end, so
Mhm.
with the iterator you do start is not equal to v.end?
I usually do, if you're iterating from beginning to end, is that what you said?
Yeah.
Then you would have your iterator start at the begin and then go to the end. Let's just, do we have the picture of it? No, we'll just go straight to the code.
So I guess my question was,
So it starts at begin, while it does not equal end, increment.
so is int.end returning the memory location of the last element?
Not quite. It's the memory location after the last element. And v dot begin, yeah.
I guess what I was confused about it, because if it was returning a value, not a memory
No.
location, if it was returning a value, you could have that before.
And let me make sure I say this correctly. It is going to behave as if it is returning the memory location after the last element. It may not actually be doing that. They may have some other implementation on the back end. But on vector, for sure, this is the way they do it. Other data structures, it's going to be different. Great questions. Any others? All right. So trying to find the max. Notice that we are just passing an iterator. Now, both of these iterators are a member of vector, so you do know that they're going to point to something that's a vector. So you want to return the max. Hopefully you can see this. M is going to be the element stored at start, what start is pointing to. And then while start does not equal stop, if what start is pointing to is greater than M, update M, otherwise increment start. So then it's just going to go through each element until it gets to the end, and then return the max.
Where'd stop come from?
It's being,
Would it be?
okay, end should be stop.
Okay.
Let me fix that now.
Because that code would have been like, why are these stops not declared?
And the compiler is always right. There we go. Better? Okay, good.
It's at the CO.
Now that one's actually correct.
Yeah, because that's the actual function.
And that's the function being called. Notice that at the begin and end, and then up there we have start and stop.
So it's using.
So this one is doing the max from the very beginning all the way to the end.
Okay.
But if you wanted to maybe the beginning to halfway through the array vector, you could pass it a different end, right? And then that would go up there, and you would get the max of the first half of the vector. Great questions. Good so far? All right. More on iterators, because there's a lot. All right, finally, this is the way I showed you to do it. What is this going to print out, real quick?
Is 12, 3, 7, 8.
Yes. Thank you, Joe. All right. Oh, yeah. Any questions on this? We did this hopefully multiple times. Good. Okay. There are different types of iterators, fortunately. It cannot be used the same way for everything. Every algorithm requires an iterator for a certain level of capability. Notice that the left is going to be the least capable and the right is the most capable. So let's see, higher is more specific, always subsumes the lower algorithm. All right, so it's either an input or an output. That's kind of a little hard to understand. But let's look at bidirectional. I think this is going to make more sense. Bidirectional, you can increment it or decrement it. Random access, you can increment it or decrement it by any amount. So this is just by one, this is by any amount. Forward just means you can only go forward, and then input and output. Don't worry about those really for this course, but those have to deal with how the iterator is hooked up in the back end. Is it hooked up to input or output? Oh yes, the for each command. Okay. Just looking at this function, what do you think it does?
Prints and
Prints
well,
in. What's in?
what's P?
Hmm? All right, we create an array. Well, actually, we define a function called show, passing an integer in, and what does that function do?
It just prints it.
It just prints it. Okay, great. Then you create an array, and it's those 4 elements again. You create a vector of those 4 elements. Great. Then we're calling for each, which is a special function. Actually, it's an interesting templated function, but we're going to leave it there. Passing in the beginning and the end, and then what's that third parameter to that function?
It is a function call that it's going to do on every element from beginning to end.
Okay, that's what semantically we wanted to do. What is that third element actually? What is it actually? We talked about this last class. Is it an integer?
Yes. No.
No. What is show?
Function.
It's a function. So it's passing a pointer to a function. So what it's going to do is it's literally going to call that function on every element from beginning to end. And since that function shows each element, what's going to be the output of this?
Oh, it's going to print 12, 3, 17, 8.
Right.
That's useful.
Yes. So also if you wanted to come up maybe with the sum, you just write a sum function, an average, or whatever other computation you wanted to do. You could do it quickly with this for each. This for each, by the way, is part of algorithm. It's not part of vectors. And the reason for that is that it may not just be vectors, it could be something else as well. And it's still the same for each function call. Okay, find. Again, this is part of algorithms. All right, the slides didn't point this out, but obviously we have jumped from containers to algorithms right now. So we're talking about different algorithms. So find, hopefully that tells you it's going to find the integer. Notice again, you still have to pass the beginning and the end vectors. That's going to be a very common, the beginning and end iterator. That's going to be very common. And then the key is to find the integer key v. So let's see. Create array, this time it has 7 elements. Then they ask for a value from the user. Okay. Then notice that the iterator, the find is going to return an iterator pointing to where that key is. And if you look it up, I believe it finds the first one, but I could be wrong. And then it's going to print out whether it's been found or not found.
So find is a boolean
No, what does find return?
index.
What's iter? So if you find returning iter, which is a type vector sub and iterator. So it's returning an iterator which points to where that value is located in the vector.
But you wouldn't have to dereference it, right? It does that for you.
You would have to dereference it if you wanted to print it out.
Oh, okay.
But to find out if it found your element or not, you just find out if find return v.n. Because if it returned v.n, then it did not find it. Otherwise, if it returned something else, then it did find it. And the iterator is pointing to the exact location of that vector, of that element, sorry.
If you wanted to see out that find function, would you do that, or would you have to put a star in the parentheses?
What do you see out? Are you printing out the memory location of the element, or you want to print out the element itself?
If you want, if I would want to print out the element itself.
Then you would have to dereference it. Yes.
Okay.
So find itself, the function itself works like a pointer.
Right. All right. Let's go ahead and do an example. Okay. So p vector dot example. We'll do find example. All right, we'll whoops. Let's go ahead and delete some stuff. All right, we'll keep the recommended way iterating. We'll just keep our old values, delete the rest. We'll go ahead and get rid of this whole starting capacity, new capacity. There we go. Let's go ahead and make sure that we have it. Compiles, great. Let's see if it prints them out. Perfect. All right, so it looks like we're good to go. Now, in order to use find, we have to include it in. We have to include algorithm. And you, what was it?
I don't think you spelled algorithm right.
Algor. Yeah, wow. There's no R, and the TI is totally. Whew. All right, that didn't happen.
It's okay.
No, that didn't happen.
Alright. What are you talking about?
So we want to know if we do find. Now we have to do ints.begin, ints.end, and what value do we want to look for? Let's look for the 22. And the question was, what's being printed out? It should be a memory location, or it should throw a giant error. Probably because it wants STD in front of this. Or
You need to do the whole SDE vector thing.
hold on, it is not happy. Oh my goodness. Here we go. Error, no matching for operator blah blah, AK to GNU normal iterator. Oh, all right. So we can't just print out find. So we actually need to create the vector of int iterator. What should we call this thing? They called it iter in the slides, but I don't like that name. It is pointing to the element, so it contains. There we go. We're almost there. Was not declaring the scope. Probably should have put standard in front of it. Let's try that again. Excellent. All right. So contains. Okay. If we try to see out contains, it's probably going to throw another error at me. Yep. So you can't even just print it out. You have to dereference it. And then it would dereference 22. If you want to know if it exists, we'll put does 22 exist? Exist. You would do contains does not equal ints.end. One, which is true.
So, how would, if like I wanted to use the find function to tell me what element 22 is at, how could you do that? So like,
Yeah, I know what you're asking.
oh, okay.
I don't think it does that. So you want index of, right?
Yeah.
All right. You want index of. Let's see if it has index of. Okay, so apparently that find does something different. So there's different finds.
See Stack Overflow.
Yeah, C Stack Overflow.
Dang.
Yep. There's a lot of finds. I don't have them all memorized. Okay. That did not help.
Does anybody else feel like they're always cutting grass?
Yep.
Like, I feel like every day I walk in here and they're cutting grass.
We're cutting the grass. It's
It is
just,
very often.
hey man,
Always.
we gotta keep that grass cut, all right?
Yeah, but like, it's every day. Like, I feel like those people people like all they do is cut on grass. Like somewhere on campus, they're cutting grass every day.
That's where the tuition goes.
Yeah.
My undergrad, the running joke was it had the best gardener to student ratio.
Yeah. That's about right.
Maybe here it has the best lawnmower to student ratio.
Probably.
They keep going. Yeah,
Always out
it's
there.
impressive. Of course, we have some huge fields,
Yeah, we do.
empty fields. Yeah.
I kid you not, like one day I thought, oh, I saw nothing, and I walked. I was driving out in the front where they have the main school, and someone was running. I'm like, really? But one day I thought I didn't see anyone cutting grass.
There's a lot of places they can build stuff.
Is
They
it worse?
build that direction.
It's the worst in the mornings when they cutting grass outside the quad early.
Yeah.
One morning during silent period of exams, they were cutting at 8:30 in the morning, and there were big signs up everywhere in the quads that said, "Remember to
Right.
stay quiet at all times, so people are studying for exams."
Yeah.
Oh, there it is. Okay.
You'd use distance.
I almost had this. I was so close. Position of 22. I should have known this. Ints dot begin minus contains. Yep. -3.
-3.
Oh, I did it backwards. Whatever. There we go. 0, 1, 2, 3. Because begins is pointing to the first one, contains pointing to the right one, so if you subtract those two pointers, you should get the right value. That makes sense. Okay. It's a great question. Any others?
That's funny though that it does that, but then you can't just output contains.
No. Yeah, that is kind of, yeah.
C++,
Yeah.
C++.
Killing me. All right, find if. Oh boy. Well, hold on. Any other questions on find? Find if. By the way, hopefully you can tell, when in doubt, Google which will lead you to Stack Overflow, but that's fine. I'm okay with that. I'm not.
Vectors. I got a
Alright.
problem with maps. Okay, dude.
All right, so notice Boolean my test, it's returning returning that the value has to be exclusively between 21 and 36. Okay. So iter find if, find an element, finds element, should be find element for which b is true. And then if it found one, it prints it, otherwise not so much. So which value is that? There's only one. 34. Now see what it's doing? Because that Boolean is testing something real quick. So if you want to, yeah, just get one element, there you go. And I bet you there's a find if with multiple elements. Probably returns a set. Probably be find set if I had to guess what it would be. Look, we're going to have the nicest lawn after this class, okay guys?
It feels like they're literally like right there. at least if you're gonna cut the grass, at least invest in some quiet lawnmowers. I don't know.
I don't think quiet lawnmowers exist.
No, they don't. But
The ones that get to me are leaf blowers. Those are the most loudest things, and all they do are blowing dirt into the air
yeah.
and producing it with their exhaust. Like this is the most
Or
useless
like the
contraption
weed
ever.
whacker things that cut the grass, like, you know what I'm talking about?
Yeah, yeah.
Yeah, those are the worst too, cause it just kicks up over there.
Yeah.
At least they have the decency. Like if you walk by, they'll stop
Right.
and they'll let you walk
That's
by
true.
before they keep going. Because I've been hit by stuff that flies from a weed eater. It hurts very badly.
All right. So count F. I wonder what that does.
It counts it.
Counts if what?
Like if it's in between those two values.
Right, so it gives you the number of elements. Okay, let's pause here.